Good day everyone. This presentation is for grade 10. We will continue our classes on distance learning of physics. So we're still at block 4, electricity and magnetism. This presentation, it will cover three main topics as we say here in this slide. First topic is attraction and repulsion. So what's the difference between a force of attraction and the force of repulsion? There are two different forces. So we will go through definition of attraction and the definition of repulsion. Section 2, it's a simple electrical field patterns. We will understand what's an electrical field and how we can draw it. The last section, we will do some experiments using electricity. We will do like 2 or 3 experiments to show how electricity is distributed between material. So please open your book on page 250. Title of attraction and repulsion. So as we discussed before, attraction is a force, repulsion also is a force, but there is a big difference between attraction and repulsion. As we discussed in the last class, every proton and electron produces an electric field. In every proton here, and electron produces an electric field. So any atom, as we discussed before, any atom, as we can see here in this figure, consists of 3 main parts or 3 elements, which are electrons outside here, is traveling outside here, and protons, neutrons, proton and neutrons. Electrons is always negative charge, proton is always positive, neutron has no charge, proton has no charge. So as we said before, if the number of electrons, as we can say here in this atom, the number here is 4, is greater than the number of proton. If electrons are greater than the number of proton, so the atom charge is negative. The charge is negative. Also, as we can say in this atom here, if the number of electrons is less than the number of proton, so the charge it will be positive. Or we can say another way, protons less than electrons, so negative charge. Proton greater than electrons, so then the charge is positive. So around any object in which the charges are not balanced, there is an electric field. So always there are an electrical field around any object. What we say is not charges are not balanced. So this one is important. Please keep it in your mind. As we will say again, if the number of electrons here, electrons are greater than number of protons, so the charge it will be negative. Charge will be negative. If the number of electrons here is less than protons, there are 3 protons here and 2 electrons, so the charge is positive. Number of electrons here are 4, protons are 3. Doesn't matter how many neutrons here. Neutron doesn't affect anything here of charge. Okay. So when a charged particle moves into the field, it feels a force. There is a force. This force, it works towards or away from the other particle, as we can see here in figure 15. So the force here, it will be towards or away. Depend on what? Depend on the charge of the particles here. So here it's a minus 1, so there is a force here, and positive, there is a force here. So like charges, negative or positive, repel each other. So the force here, there is a force here, it's called what? Repulsion. The force here is repulsion. So the same ones, positive or minus, like charges, repel each other. Unlike charges is different. So this one it's what? This one it's toward, it's away. The force here, it will push this one this way and push the other one this way. Same as here. Here, unlike charges, attract each other. Unlike charges, this one is positive and this one is negative. So there is a force here. What's the force here? The force here is attraction force. The strength of the force here, or here, it depends on two things. First one, how close the particles are. How they are close to each other, here or here, like or unlike. So the closer they are, the larger the force. The closer they are. So if this one is more closer here and here, so the force here, it will affect this way. It's unlike this one. This one will affect out, and this will affect where? Towards. So that how close the particle, the closer they are, the larger the force. Point number two, how much electricity charge they carry. How much electricity of a charge they are carrying. So the more charge, the larger the force. The more charge, if the charge is more, so the large is the force. Here, the larger the force, the closer they are, the larger the force. So it depends on two things, how they are close to each other and how much electricity they are carrying. Okay. So please have a look at figure 4.16. Say this guy here, this point, says here. So when unbalanced charges collected on a surface of an object, when unbalanced charge, there is an unbalanced charge here collected on the surface of an object. The charge is called what? The charge is called static charge. This one is static charge. What does it mean by static? Static means not moving. If moving, there is another thing is there. When electrons move or flow from one place to another, for example, from place here to place here, so they produce electrical current or electric current. So if they are not moving, so the charge is called what? Static charge. If the electrons are moving, they say, or they is known as electric current. There is an electric current. So because of a static charge here on each hair here is similar, the charge is similar, positive or negative, the hairs repel each other. They are repel each other and stick up in all directions, as you can see in this figure here. Okay, now we'll move to simple electrical field patterns. So please turn in your book on page 251, 251, and have a look at figure 417. Figure 417. Figure 417 is an electric field around a point charge. There is a point charge here, as we can see here. The electric field around any point here, it's whatever is positive or negative. So if the point it points out, the electrical field here, it points out when in straight lines from a positive charge. So that if the charge is positive, so the lines it points out, straight lines out of what? Of the charges, the charge here. And points inwards or inside when also in straight lines towards a negative charge. So if the charge is negative, so the lines of electrical field it points inwards. But if the charge is positive, so the lines it points where? Out. It points out. Depends on so the direction of electrical field pattern. The pattern of any electrical field it depends on what the charge of the point. If the point is negative, so the charge is points towards the charge, and if the charge is positive, so the lines it points out in straight lines. There is another example showing the pattern of electrical field, as we can see here. So electrical field around two parallel plates with opposite charge, so the charge is different. This plate is positive, I think positive, yes, and this one is minus. Two plates, plate number 1 and the plate number 2. So when the two parallel plates with opposite charge is shown here, the field lines are evenly spaced between the plates except the end of them. So the lines here it will be comes in straight lines because the charge here is very strong. The lines it will be in, I think we discussed this one in last topic. So the lines here it will be what? Straight lines because the charge here is very strong. At the end here it will take like a curve. It comes from positive to minus, positive to minus, moving this way. See here. We will show some experiment as we discussed, I think, last chapter. We discussed like iron filings, I think. We will show how an iron filling is distributed by using some magnetic field. So from figure 4.18, what's the conclusion here? The conclusion is the field lines are evenly spaced between the plates here. Evenly, it's straight lines. It comes in straight lines. But at the end, no. It's like a curve. So we will go to, we will show some video here distributing. By this video, we will show how those lines are distributed between two different magnetic poles, like NS poles, or different plates here, positive, minus, it's the same. So have a look, please, at this video. So what we will have here, we will have a magnetic, this is a magnet, stack of magnet, NS poles here. So we will put like a tiny sheet of plastic. We will cover the magnet, and then say what happened here. So this, and what we will do here, we sprinkle some iron fillings on the top of the plastic cover or plastic sheet, and see how the lines it will come. With some knock. say the line is here, this N compass. If we put the compass here, you will say NS balls, NS balls. Those the line is, this is the north. So the lines that comes from there up to here, say here is straight line is, it comes from here to here. And the lines comes here, the magnetic field. Yeah. Here the lines are straight lines, and the other lines it comes like a curve from N to S balls from both sides. See? Say if you move the plastic cover, say what will happen. Okay, now we will do another simple experiments using electricity. So please turn in your book on page 251 and have a look at figure 419, as we can see here in this figure. So similarly, when a balloon is rubbed against clothing, it will stick to a wall or ceiling. So if the balloon here is rubbed with some clothing or clouds, it will stick on a surface of wall or a ceiling. This is because the traction between the negative charge here of the balloon is negative, and induced positive charge of ceiling. Say here, this is an the balloon is negative charge. So what will happen here? So the positive, it will come here because the attraction force, and the -1, it will go this way. So electrons, this one what? -1 is electrons, the positive one is proton. So electrons repeat away. Electrons, they will move this way. Why? Because they are same charge, minus, minus, or negative, negative. They will repel each other. And the positive, it will move this way because what? Attraction force, because they are different. So this is because of the traction between the negative charges on the balloon and induced positive charge on the ceiling. So we will go through some experiment, another one, or the last one. The last one here is any object can be charged by a process known as what? Induction. So what's the induction? Any object can be charged, positive or minus is charged by a process known as induction. So example of this are picking up a small piece of paper here, as we say here, this small piece of paper. So picking up small pieces of paper using a comb. By using a comb that you have rubbed on an item of clothing. So both of them, they will have different charge. This one, it will have like minus, and this one is positive. So there is an attraction force here, attraction force between the comb and the papers, small papers here. Or another way, you can use a charged comb to bend the stream of water away from a tap. So you can use this one, the charged comb here, to bend stream of water away from a tap. So this is all for today, and next class we will go through we will solve some questions on those topics. So please ready for that, and that's all for today. Thanks for listening. If you have any questions, please feel free to contact me, and I'm happy to answer your question. Thanks and good day.